Alright guys, so suppose our multiple choice quiz on quantum electrodynamics, which we still know nothing about, has 20 questions, each with 5 answer choices. On this slide, we're just going to write the formula. So I'm going to write it exactly how I want you to write it on your test and on your quizzes and also on the AP exam. And then on the next slide, I'm going to show you how to write it in the calculator. So what is the probability you get exactly 10 questions right? Before we start, let's talk about what n is. N is going to be 20. There's 20 questions. P is 0.2. How did we get 0.2? Well, there's 5 answer choices, so 1 out of 5 gives me 0.2. K is what the question's asking. So what is the probability you get exactly 10 questions right? So K is going to be 10 for this question. So I want to find when x is equal to 10. I'm going to write my binomial coefficient, which is 20. Choose 10. Probability is 0.2 to the k times 1 minus p, which is 0.8, to the n minus k. I'll rewrite that formula just so you guys know. This is on the reference sheet again, just so you remember that you don't have to memorize this formula. All right, next question. What is the probability you get at most 10 questions right? At most 10 questions right means no more than 10. So from 0 all the way up to 10. So how I'm going to write that is I have 20 questions, choose 0. I get none of them right. Plus all the way up to 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't want to write all that, so I'm going to just write plus dot 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 plus. That's the math notation for writing the continuous amount up to the number that we want, which is 10. Your exponents should add up to n. So 10 plus 10 gives me 20, which is correct, and then 20 plus 0 gives me 20. So your exponent should add up to the number of to n, the number of observations. Last question. What is the probability you get at least 10 questions right? So that means 10 or more. So it's probably when x is greater than or equal to 10. And here I want 20 questions. Choose 10. I'm going to start with 10. And then go up to 20 because I have 20 questions. And I'm going to run out of room. Sorry, guys. Okay, so this is just writing it out, how I want you to write it out on your test and on your quizzes, also on the AP exam. Now let's talk about what we're going to put in the calculator. So if it's exactly 10 questions right, we're going to do a binomial PDF. Binomial PDF is found under second vars in your calculator. If you forgot where that is, come see me and I can show you. And remember, whenever we put it in the calculator, we're doing NPK. So since it's exactly 10, I'm using binomial PDF. There's 20 questions. The probability is 0.2, and I want, when I get 10 questions right, plug that into the calculator and see what you get. And you should have gotten 0.002. What is the probability that you get at most 10 questions right? So whenever you're doing an inequality from 0 to a number, we're going to do binomial CDF. And it's still NPK. So we have 20 questions, probably still 0.2 up to 10. Remember, your calculator goes from 0 up to a number. So when it says at most 10 means from 0 to 10. So our calculator is doing from 0 to 10, so we're okay on this. Plug that into your calculator and see what you get. You should have gotten 0.9994. Now this makes sense. You're guessing on a 20 question test, multiple choice, 5 answer choices. What's the probability that you get at most questions right? So less than half the questions on the test right. 99.9% chance. That makes sense. Last question. What is the probability you get at least 10 questions right? So at least 10 means 10 or more, so 10 to 20. And now remember, the calculator only does from 0 to a number. So I'm going to do 1 minus what I don't want. I don't want from 0 to 9. So I'm going to do binomial CDF 20.2 NP, and then K for here is what I don't want. So K is up to 9 and 1 minus. Remember, the probabilities always add up to 1. If X is greater than or equal to 10, think back to the normal curve. Whenever we did greater than, we subtracted by 1. We did 1 minus. Same thing here with the binomial distribution. Anytime we have a greater than sign, we're going to do 1 minus. Now let's go ahead and plug that into our calculator. And that gives me 0.0026. The probability that you would get at least 10 questions right on a 20 question test that you completely guessed on, spread the word, tell your friends, is 0.002. So not even 1%. So don't even try. So what we're going to talk about today is mean and standard deviation of a binomial random variable. I'm not going to bother to derive these, but it wouldn't be that hard to do it. You know how to find the mean and standard deviation for a discrete random variable. That was from chapter 7. And guess what? These are on the AP formula sheet, so we don't even have to memorize these formulas. Mean of a binomial distribution is just n times p, and the standard deviation of a binomial distribution is n times p times 1 minus p square rooted. These are only good for binomial distributions. Remember the 4 conditions for a binomial distribution. The first one is, do we have success and failure? The second one, is there independence? Sorry, I'm rewriting because I don't like this screen. The third one, do we have a fixed number of observations? And the fourth one is, are all the probabilities the same? Make sure these 4 conditions are met before we do binomial distributions. So, suppose we still have the same question that we began with. Suppose our multiple choice quiz on QED, which we still know nothing about, has 20 questions and 5 answer choices. The mean, remember the formula I wrote right down here for you. This is on the reference sheet. So the mean is n times p. N is 20, and p is 0.2, which gives me 4. The standard deviation is the square root of n times p times 1 minus p down here. So 20 times 0.2 times 0.8, and that gives me 1 point something. Hold on, let me check. 78885. And it's that simple. This is on, remember, this is on the reference sheet, so just look for it, and you don't even have to memorize it. The normal approximation, if n, the number of trials, gets too big, your calculator cannot handle the calculation. So fortunately, as n gets larger, the binomial distribution approaches the normal distribution, and we already know how to use this. Normal distribution, remember we use z-score, the normal curve, x minus mean over standard deviation. When n is sufficiently large, we can approximate this distribution for binomial using the normal distribution. So what's the approximation and what's sufficiently large? Well, sufficiently large is when we meet these two conditions. N times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. This is both. Both of these conditions need to be met and need to be satisfied in order for us to use a normal approximation. If the above conditions are satisfied, our distribution is approximately normal with a mean of n times p and a standard deviation of the square root of n times p times 1 minus p. Suppose you ask a sample of 2,500 adults if they find shopping frustrating and time-consuming. Suppose further that 60% of the U.S. population agree with this statement. What is the probability that 1,520 or more of your sample agree? We're going to use a binomial calculation for this problem. Now notice, n is 2,500. That seems like a pretty big number. So on the next slide, we are going to use a normal approximation. But for now, our calculator can calculate the binomial distribution, so we are going to do it using the binomial distribution. P, they told us, was 0.6 or 60%. For here, I'm trying to find when x is 1,520 or more, so greater than or equal to 1,520. So how I'm going to write this is my n is 2,500. Choose 1,520. Probability is 0.6 to the 1,520. You see how complicated this looks for your poor calculators? That's why we can use a normal approximation for this. I'm going to go ahead and put this in the calculator. We're doing, it's greater than, so 1 minus binomial CDF. N is 2,500. Probability is 0.6. And K of what I don't want. Remember, it's 1 minus, so it's everything that I don't want. Up to 1,519. And that gives me a probability of 0.213. Now let's do it using the normal approximation and see how close we get to 21.3%. Well, first, before we use the normal approximation, we have to check the conditions. Remember, the conditions was n times p has to be greater than or equal to 10, and n times 1 minus p has to be greater than or equal to 10. So let's test that. 2,500 times 0.6, is it greater than or equal to 10? Yes, it is. 1,500 is much larger than 10. And then 2,500 times 1 minus p, or 0.4, is that greater than or equal to 10? 1,000? Yes, it is. So we are good. We can use the normal approximation. For z-score, remember we need an x value, a mean, and a standard deviation. The mean for a binomial distribution is n times p, so I'm going to do 2,500 times 0.6, which we already did over here, so I already have that number, 1,500. And the standard deviation is the square root of n times p times 1 minus p. and that gives me 24.495. Now we can do our z-score. So z equals, remember the question was 1,520 or more, so 1,520 is my x value minus the mean over the standard deviation, and that gives me a z-score of 0.82. When I look that up in the chart, I'm going to draw my normal curve. I want more than, so I'm going to shade to the right. This gives me 0.7939. So this area, when I do 1 minus that, is 0.2061. Remember on the last slide, it was 0.213 for a binomial approximation, and we got 0.2061. Pretty close, right, for a normal approximation. Here's the homework number 2 for section 8.1.